My name is Matt Moyer. I'm from SAMSON Controls. A little bit of background on me. I was originally a chemical engineer. I've been about 10 years in the process industry, from selling control valves to instrumentation, from working in engineering firms, all the way up to end users such as DuPont. So going to talk to you a little bit about ISO 15926 today. So I guess show of hands, does anybody have any familiarity with 15926? One person, Thor. Okay. Well, that's good because that means I can talk a lot and you guys really won't even know if I'm right or not. So here we go. And I should preface this with a little bit. I'm filling in for our CTO, who was originally going to be coming in and doing this talk, but I have spent a lot of time working with 15926, and I hope that you guys can take a little bit of information away from this. Okay, so. You want, oh, is there a, oh, I'm sorry. I got mine. Okay, good. Okay, so as we start to talk about ISO 15926, I want to talk about the reasons why we get into this. And the first thing that you can see right now is the interoperability and the cost it actually creates in there. So from the source I have right here, $5.8 billion per year in 2004. So you can only imagine what those numbers have come to today. So the reasons what we're talking about interoperability. So it's easy for me to kind of give you an example. Working for a German company that makes control valves, specification sheets that we need to define pieces of equipment maybe 10 years ago. We request the information from Germany. It comes over in a specification sheet that's in German, and we have to translate that over. Those inefficiencies, especially for a global company like SAMSON, when we have world areas and production facilities in China, India, and we're doing projects all over the world in Brazil, problems that can arise from that, and you can see these inefficiencies of that $5.8 billion a year arise from problems with us not being able to transfer that data over correctly. When we're transferring over those specification sheets, sometimes data can get lost, sometimes specifications can get mislabeled, and there's a lot of problems that can be generated inside of that. So today, what we talk about is how ISO came about, how the standards kind of work, and what the end goals are trying to achieve in terms of this interoperability and standardization across these different companies. So as I start to talk, I want to hit on two key objectives of what ISO 15926 is trying to achieve. So the first objective, as you can see, is define a characteristic of free communication between all of the users. So we're talking about manufacturers to EPCs to consultants to the end user level, where we want to be able to set up a standardization that there's easy interoperability between the different organizations. So as I see there, a characteristic of what the system would interfaces are completely understood to work together. So this is what it's talking about, is being able to create a simple language so that all of our computers, all of our software, all of our sizing tools, from the manufacturer over to the EPC, to the end user, to the purchaser, are able to talk together easily so that there's no misinformation being lost and that there's nothing that we're being lost across different languages or world areas. So the other aspect of what 1592 is trying to achieve is archiving. So when we talk about archiving, it's a way that we can store the data in an area that we can then go back and retroactively apply these machine learning algorithms, artificial intelligence to the data. So by making it easy to extract that data in an easy format where everybody can understand it and interpret it, it makes it better for us to be able to create easy to use softwares to optimize what we're trying to do. So you can also get it into root cause failure analysis and then helping you to specify equipment in the future. So as I start to talk about that, let's go into a little bit about, I'm sorry, exactly how information is supposed to work as we flow through there. So many organizations put it in capital projects. So here you can kind of see if we're specifying a pump here. So you've got your constructors, you've got engineers, purchasing agents, manufacturers. Each and every single person has a little bit of different interest in what's going on inside of this pump. But the data is still the same. It's still the same pump across there. And the problem is that now in this global type of market is that we'll have EPCs in one country, end users and manufacturers all over the place. So the problem is in that the way that it's supposed to work is that everybody can easily get that information out of what they want. The purchasing agent, he's only concerned about really what the price is on there. My constructor, he wants to know what the weights and the dimensions are. And maybe my specification engineer, he wants to know the actual process data that's going in there. And to think about it, you'd think that it'd be a simple, easy way to share the information across there. Everybody would make money. But as you saw before, like I talked about, they've noticed that there's $5.8 billion worth of losses in this. So bringing standardization into this will help drive down costs for end users. It will help make easier software applications, easier points of entry for other users. So as we talk about how the information exchange actually works. So this is kind of how it would work. So say my German counterpart sends me over a specification sheet and he doesn't speak any English. I get that and I pass that along to the end user purchaser, and I don't do the due diligence of having to translate that for them. Information could get lost to that purchaser in terms of what he's looking for, in terms of what he wants to buy. And then when I give that to the contractor, we could end up losing information on the weights, the specifications of the sizes. So it really gets important to make sure that what each and every single person is looking for in there can be easily extracted out of that data. So how information is supposed to work with ISO 15926. The point is that as companies and developers are setting up and specifying equipment for process industries, that we're looking at it, we say, I'm going to send it into a simple language that everybody can understand so that when I extract that data out of there, I'm able to grab the information in the pieces that I need, in the language that I need, in the time that I need, without extra costs, without extra sourcing, without extra money being involved in that. So, as I said before, I'm a process engineer, not a computer science engineer, but these next 3 slides that I'm going to go over are very important for you to kind of understand what the individual parts of ISO 15926 are. So as I start to talk about this, it's really now made up of almost, I think, 13 parts, but there's really what I'm going to go through is the key 5 parts of this. So the first 2 parts that we're talking about is actually how they're going to talk. And you can think of this as, say you and your friend were going to come up with a new language. The first thing that you guys would probably do to come up with your new language is probably define a dictionary of words that are going to be in there. And then you would set the rules for the grammar on how you're going to talk. And this is what we're doing between these companies, these software manufacturers, the end users, the vendors, the EPCs. Everybody needs to come up with a common language. And with that, and like I talked about before, it'll achieve that first goal of creating a common language so that computer systems are easily able to communicate with each other to help reduce costs, inefficiencies, and help to bring more value to our customers. So that essentially is what parts 2 and 4 are trying to accomplish. So as we move over to part 7 is really just to expand on part 4 to be able to add more context to that data. So when I'm submitting out my files and it goes to a purchasing agent, he's not concerned with necessarily some of the specifications that I put on there in terms of the CV value for maybe a control valve or what the protocol of the operating protocol of the positioner is going to be. He's more concerned about what it's going to be in terms of the pricing. So what we want to do is we want to help define context. So we add phrasings to this. Now again, this is all into the underlining program of how we're going to create this language and how it's going to communicate between companies. So then we go to parts 8 and 9. So part 8 and 9 really accomplish that second part that I had hit on before, where we're archiving the data. So this is, we talked about, I gave my example of 2 people trying to create their own common language. Eventually it's going to get to the point where you write that language down, where you have a common set of areas on a piece of paper, whether it's on a whiteboard, whether it's on the internet, somewhere out there exists where you're going to write this data. And that gets into the archiving of where this data is going to be stored so that you can easily extract it out for artificial intelligence purposes, whatever it may be, so that you can do optimizations, root cause failure analysis. And that's really the key point of part 9 and parts 8 and 9 is the archiving of that data like I talked about before. So in summary, like I was talking about before, parts 2 and 4 in conjunction with part 7 make it easy for them to kind of communicate between each other. And these are softwares, computers, easily being able to communicate in a common language. Part 8 and 9 are the methods of accessing that information, where it's stored, how you access it, and that ultimately gets into being able to apply artificial intelligence, machine learning to all that data inside of your facilities. So, summary. Short answer on ISO 15926. It's a way of representing information easily exchangeable, easily accessible across all platforms for end users, vendors, customers, whoever it may be. So the end goal, any owner, EPC, vendor, constructor will be able to access this life cycle data at any point in the process and seamlessly with business partners, regardless of the commercial plant design and software that's being used. So how do we get this to drive this? So in the industry right now, the only way that we're gonna see this driven home is by the actual end users, because it's gonna take the software companies to come up and actually see that they're gonna have to provide this for the end users. But it's the goal of the end users to adopt this, because ultimately there will be cost savings that can be passed on to the end users, and those inefficiencies can be reduced. So in summary, I wanted to kind of leave with exactly what it could get you. So this is an illustration of an example. Say your plant's been running for 10 years, you have 1,800 pumps out there, and you've gone through this process of standardizing everything so that all of your data is easily accessible. You can apply machine learning algorithms, AI, to be able to look at that data so that in the future when you're going out to expand and you want to put a new pump into the system, that you can apply that without needing to go out to vendors, without needing to go out to the contractors, EPCs to do the engineering, and you can learn from your plant itself and get the specifications printed out for those. So, and like they say, you can lead a horse to water, but you can't make him drink. And in order for ISO 15926 to be adopted across the industry, we need thirsty horses and the end users who are going to demand this, because it's ultimately, in the end, going to benefit everybody as a whole. So that's why we drive to completion.
Thank you. Matt, so maybe if you can join me here, we can have a quick Q&A, kind of. So thanks for the presentation. I know you introduced yourselves, but maybe can you talk a little bit about your company? Just give us a little bit of an introduction.
You guys hear me? Yeah. So SAMSON Controls has been manufacturing process control equipment, from regulators to control valves to smart positioners, for over 100 years. They were founded in Mannheim, Germany, right at the early beginnings of the 1900s. Grew up in the chemical industry alongside the Bayer, the BASFs of the world. So in 1915, we moved to Frankfurt, Germany, where our home office is now. We have 33 acres, and it's one of the biggest control valve manufacturing sites in the world. So you may be wondering why a manufacturer of control valves is here, but we noticed that there's a shift in the industry to a more digital revolution. So 5 years ago, we actually acquired a software company for predictive analytics in the process industry. So it's kind of why, and as we start to develop our smart positioners and we come up with more digital solutions, why SAMSON's here, the IoT.
So are the applications mainly in chemicals, or can you apply them more?
No. So it's across all industries: pulp and paper, oil and gas, refining, petrochemical, pharmaceuticals, chemical. I must admit that the majority and the bulk of our sales do focus on chemical, pharmaceutical, petrochemical type industries, but we have plenty of solutions for the refining industry and oil and gas and anything else.
So one of the big challenges in the oil and gas industry is methane emissions, fugitive methane emissions. I wonder, and there's been a little bit of development and new product introduction around valves that try to mitigate methane emissions. Is that something that you guys have been working on, or are there intrinsic advantages with your valves?
Yeah, so that's a really good question. And from my background specifically, I'd started up with a different valve manufacturer in the world. They make green actuators, Fisher Controls. And when I started in 2010, the kind of industry was moving towards LDAR, and that's a focus on looking at the emissions that are coming out of the packing of the control valves. So what we were trying to do was actually kind of get to the European standards, because Europe was ahead of us in terms of the emissions that were coming out of the packings and the control valves. So if you actually look at SAMSON as a company, we have started well before the United States and really North America kind of moved towards this, looking at 100,000 ppm per lumens or anything like that with the LDAR directives. So with our packing, we've been able to actually meet those standards well before the industry here in the United States moved to it. And I should mention that with SAMSON, one of the key things that we focused on and what actually brought SAMSON up was the invention of a bellows seal. So when we talk about emissions through control valves, we're looking at packing and then obviously leaks that can happen through flanges. With a bellows seal, it provides zero leakage, and that's one of the things that SAMSON's famous for, and that was one of the original patents of SAMSON.
Excellent, that's helpful. So maybe let's come back to the issue of interoperability standards and things like that. So clearly it's a big number, right, in terms of $5.86 billion of losses because of the lack of adequate standards. Where is that coming from? Is that primarily work that has to be redone? Is
Yeah.
it
It's a lot of inefficiencies, and you can just think of at an EPC the hours that are spent having to convert over documents between different engineering sources. Maybe the company that you're buying the equipment from is specified out of China, and that you have to take those documents and you have to convert them over in a way that you can give to your end user. But if there's a common type of protocol, like CAD drawings use step files, where I can be in China and I can use a certain CAD drawing program, and I send that document to somebody in the United States and he opens it up on his CAD file program where all that information is still retained. It's converted over into English for me to be able to read from the step file that they converted over from China. That's where we kind of need to get to in the and that's what the focus is of 15926 is to drive down those inefficiencies. And then you got to think about the converting over units between SIs and anytime that you're doing that, there could be loss of information. So it really reduces that. So there's problems with missupplying equipment, specifications being wrong, all the way down to the construction of it.
asset, the capital project, you mean?
Yeah.
Yeah. So I'm assuming there's some cost associated with the fact that there's the expectation that organizations would have to spend some time addressing these standards, right? So there's probably some inbuilt inefficiencies or time that is built into projects just because of the expectation that there will be challenges with getting data in the right standard.
Right. So one of the biggest ways is just reducing hours at EPC firms that are going to get billed to a customer in terms of the overall engineering. And then when you're trying to bring a project online, if you can bring it on a month before by reducing all these inefficiencies all the way from the initial design engineering to the detailed engineering, all the way to the specifications and building of it, all throughout there, if you're able to bring a project on a month earlier, there's just more money being made.
Yeah. Is the bulk of the cost because of the delays a capital project endures, or is it actually in rework and the number of hours? I don't know if you know this.
I honestly can't comment of what that number of 5.8 billion, what it was made
the
up
breakdown
of
looks like.
where they were all falling from, whether it was like you said, rework, misapplied equipment, having to rebuy them.
No worries. So can you talk a little bit about maybe, so you described what information flows need to look like and what they actually look like. But what does it take for an organization to kind of climb up that maturity curve to the point where they can communicate with others using this ISO standard?
So I guess I would use SAMSON maybe as an example, because we have sizing programs that will output specification sheets, sizing data, but it's all in PDF form. So what we want to do, and in order for us to be able to convert that over into the standards of ISO 15926, is that we'd have to hire programmers that would be able to take that data from the point of where we're generating it onto the specification sheet, take that into what we talked about before, where I was talking about the programming language, to make it easily accessible so that somebody else in a different organization who might not have the program specifically is called CSAM, to size control valves. He might not have CSAM to be able to open up that document and read those informations, but because I've converted it over to a common language, and he then adapts that common language that he has to have on his end to be able to then interpret it for his software. So it's going to take conjunction of, it can't just be us building this software and spitting out the language. Somebody has to have the software enabled to be able to interpret the language too and convert that over. So, and that's why I say that, where I said that in the end, where the only people that are going to drive that is the oil and gas industry, that's going to demand that from the vendors, from the EPCs, that when they get their information sent to them, they're all ready to accept it in that format. So it will drive us as manufacturers, EPCs, to have to give them that information, which would mean we'd have to hire the programmers to write the language. But it's all standardized and it's all open source for people to be understand. Not myself, I'm not a computer science engineer, but other people can.
Yeah. But do you think that the driver has to be the operator, the operator universe, right? Companies that are executing oil and gas capital projects.
Yes, it would be a tough sell for me to try to get my VP here to fork over some money for an end user who's not yet ready to even accept that. So once the end users are demanding it and they say, this is the format that you will give this to me in, I will only buy from companies that give it to me in this format, then that's when we'll see the rest of the industry start to follow.
What will it do though to the cost structure of capital projects? Like if suddenly you were supposed to follow these new standards right down to the T, I guess what does that do to your cost structure?
If I haven't yet developed the standards in my software, well, I think,
Or adopt them for sure.
well, I guess in a capital project, I wouldn't try to necessarily pass that initial one off to my customer, but for capital projects, if we adopt it beforehand and we say partner with EPCs that are also adopting this, or maybe partner with a transmitter company, and we all come together, we can be more competitive than, say, an Emerson of the world who's got everything under their belts, because we're able to offer and have in between us more efficiencies, less money, less cost in terms of the engineering and design.
Yeah. I mean, the challenge is, the way I see it is that there's clearly value to be generated because you're reducing rework and all of that. But there's also a little bit of an investment, even if it's a small one, that has to be made by all stakeholders to kind of get ready and provide information in this format, right?
Right.
According to these standards. But the bulk of the value probably accrues to the capital project owner. Or do you see some of that value potentially flowing back to the vendors, EPCs, and other suppliers?
Yeah, I couldn't really comment on what the return on investment would be right away, because I don't really know necessarily what a programmer would cost to be able to convert CSAM into the ISO 15926 format. But of course, the goal is to ultimately reduce costs from vendors to end users. So I think of it like the standardization of the rail line industry. Before, in the United States, you had rail lines that the gauges between the tracks were all over the place. And by standardizing on that, you come up with, the manufacturers of the rail lines are able to reduce costs via leveraging large inventories, to the people that are building it via just standardized rail lines that you don't have to re-engineer. So when we talk about that, for us as a company, while there might be an initial investment that we have to overcome, the goals throughout, and as everybody moves towards this, the savings, I think, would definitely outweigh. What the return on investment, I'm not sure.
Yeah, okay. So are there industries that are further along, or is, I'm curious, like, where does the oil and gas industry fall?
So from all of the research I've done, the oil and gas industry is actually the driver of these types of 15926.
Okay.
So they're the ones that have been working in conjunction. It was really brought up out of that to try to because of these large capital projects, and just because of the amount of just life cycle equipment that you're trying to understand at these refineries, or I'm sorry, oil and gas plants to refineries, where you've just got so much equipment out there.
Are there competing standards? Is this just an issue of adoption, or is it also an issue of choice, or like are there other competing standards?
No, one of the slides that I kind of went through there very quickly kind of talked about how this originated in Europe in 1993, and with oil and gas companies and some of the big industries actually adopting it, became a standard, an ISO standard 15926 in 2000, and I believe it was 2006 that I showed on that slide. So it has become I guess the choice standardization, and
the reason why it was adopted into an ISO standard was because of the acceptance throughout the world in industries. So in terms of a competitor, I couldn't see one being competing with ISO in terms of the standardizations for
Okay.
that.
So what is preventing the adoption right now? Why aren't more?
It's a very complicated process. As I put those 5 different parts of it, and I mentioned that there's 13 parts. It goes into all of these software companies with lots of different features that they're trying to provide for end users or EPCs, and how they're going to program it to get exactly what their piece of that, as I showed before, is everybody's coming together and they have different portions of that pump that they're specifying, how they're going to bring their pieces together.
Okay. And there aren't vendors who actually help companies move this along already? Like,
So if you, there are some references on some of the ISO pages that I've been researching, and there are companies out there right now. There are a couple of case studies of actual oil and gas companies in Europe that have adopted this type of model, and that they've been able to retroactively apply machine learning or artificial intelligence to be able to look at that data that's archived in there, because it's so simple and easy to use across multiple of their organizations too. So when you think about a company that owns refining operations in China as well as India, they could be on completely different platforms, and they want to be able to review that data from one central location. They need that all on one central language to be able to talk to each other.
okay. So if you think of the oil and gas industry and you say upstream, midstream and LNG, downstream refining, petrochemicals, are there certain segments where deploying this would be easier, faster relative to others?
I don't think so specifically. I mean, it all goes into being able to capture that data that's in there for specifying equipment, whether you're in a process facility doing chemicals, pharmaceuticals, or anywhere in the oil and gas, upstream, midstream, downstream.
But maybe another way then to segment this is in terms of the size of capital projects. Maybe the smaller capital projects are a good way to kind of pilot this, get your
Yeah.
feet wet, understand how it works, and then deploy it into.
So if you do read some of the case studies where the European companies that have tried this, they are doing it at pilot plants where they're rolling it out, and they're doing experiments to see what they can actually do with that data. That's where I go back to applying artificial intelligence and machine learning to that data, because they're now that they have all. Before, they knew that they had 1,800 pumps in a facility, but how did you really be able to understand everything that was going on inside of those? Because you didn't have them all in one location where you could easily just extract all that data. They might be on 1,000 different specification sheets where this purchasing manager might have bought them before, and this is just centralizing all that data so that you can easily apply algorithms, whatever it may be, to the data.
Yeah. So maybe can you talk a little bit about some of the case studies and what you have seen are interesting applications?
So I really can't talk to too many of the case studies, unfortunately, because I wasn't really involved in any of them. But from what I've seen is that it is lowering the cost of being able to do predictive maintenance for these, and in terms of specifying new equipment, and also in terms of optimization, where they can go back and kind of look at their processes and try to figure out where inefficiencies are.
Okay. And how does it do that? Because all the data is in a central repository and everybody is looking probably at the same set of data, it makes, I guess, some of these
So, and part of the ISO 15926 and why it's taken so long with this adoption is because not only are they trying to come up with an easy way to be able to log just, say, 4-inch pumps this much, but they also want to be able to find a way to be able to log all of the operating data too, how this pump's being performing, so that you can go back there and you can look through the history of the performance as well. So that's why as ISO 15926 continues to be rolled out, people continue to add more into this, because they realize that there's so much data out there that they can glean from that.
Okay, that's interesting. So I have a couple more questions, but we have another 10 minutes or so, and maybe I want to open it up for additional questions from the floor. You can go to slido.com, use IoT as the code, as the token, and send your questions. So coming back to this issue of like gathering data that then allows you to kind of get visibility around aftermarket maintenance, optimization, and all of that stuff. Um, the So there are benefits to this that go well beyond just the capital project, right? Because there's significant aftermarket spend. I mean, once
Oh,
you
right.
guys sell a valve, there's
And that's
significant.
really the second portion that I hit on is being able to understand your process more, because it really deals with the archiving of that data. When you have those mountains of data, it's how do you analyze that? And this, what everybody's here talking about is what you can do with all of that data. And that's what it's talking about, is being able to store all of that data in a nice, easy way to find, whether it's my steam traps, my control valves, maybe it's some type of rotating equipment that I'm trying to make sure that I'm managing properly.
Okay. What do you see are some of the other advantages on a more broader basis of these standards? Do you, potentially there's some data flow back and forth between end users and vendors that maybe allow you to kind of do better product development?
So I think that, you know, say for instance that you're looking to bid a job to two different EPCs, where before in the past, maybe working with an EPC in China or a foreign country would have been so cumbersome because of the language barriers and the different methods and way that you do things and the specification sheets that come over, where you'd have to go with a more expensive option in the United States because of that. Well, now because we're becoming more globalized and that we write a standard language, it'll open the doors up to be able to work with international companies more, and it'll just help drive down costs and ultimately for the end users and customers.
Okay, that's a very interesting point. So what you're saying is some of the information asymmetry that might exist because operators are unwilling to try a brand that's not as well known as, say, Emerson. So
Yeah.
by using these common standards, some of that, I guess, brand-related reputational assessment kind of becomes less important
Hmm.
in kind of picking new
Right.
vendors, suppliers.
Exactly. If you're used to seeing a Fisher specification sheet, and then it's no longer that, every time that you get one from, say, a Nellis Jamesbury, you can't even understand it. But now because they're this simple format that everybody's standardized, it doesn't matter who you're talking to as a vendor, you're going to still be able to get that same information out of it.
Right, right. That's a very interesting point, right? Because not only are you not only are you gaining cost efficiencies because you are executing a project a lot more efficiently, but you potentially now have access to a broader range of potentially much lower cost suppliers.
Right. Right.
So if I flip the lens and look at the issue from the point of view of a supplier,
Hmm.
a vendor, um, or larger players, like would your former employer Emerson be better positioned to kind of deploy some of these standards relative to, let's say, a smaller company?
Well, so I can't really necessarily comment on the cost of the programming to be able to do that. And of course, Emerson's got a lot of different, from the AMSs to a lot of those different programs, as well as SAMSON does, as any other.
Mhm.
But for a larger organization, just because that they have more capital, I would think it would be easier for them to get into this type of markets here. But it's all open source, and as more of these big companies take the lead and they figure out these ways to program to be able to archive that data. And since it's open source, it will only help benefit those smaller companies that might not be able to put the resources to developing it. And that's why, as you go out there and you look, there's so many organizations that are nonprofit trying to promote this because they know the benefits of getting there. But the problem is, who's going to really take charge and lead this? And that's why I say it has to be driven from the end users, because I can't get my boss to sign over on doing something if I can't justify it for why it needs to be done.
Right. Yeah. No, makes sense. So there are a couple of questions here. So one is a question on how do you see procurement becoming a partner to get ISO requirements into contracts?
So in terms of procurement, that was one of the key portions of one of those aspects of people, that it really matters that they're getting that right data. Like I talked about before, I'm specifying sizing data all the way to the materials of the valve. And for an engineer, he might be like, great, I want to see all of that on that documentation sheet. I send that over to the purchasing agent. He's looking at those numbers and they don't mean anything to him. And all he really cares about is, what's the price of this valve and how do I get that out of there? And so by giving that to him in an easy to use format, it might be able to be able to bid jobs easier, to be able to look at and compare different quotes from different vendors, they might be able to get more quotes from different vendors to help drive down costs for procurement.
Yeah. So, I mean, this reminds me of some of the conversations that we were having yesterday around smart contracts, right? One of the attendees here is with Data Gumbo. They specialize in smart contracts, and one of the things she said is, conceptually, smart contracts can create a lot of value, and adopters have seen tremendous amount of value that has been created because of the adoption of smart contracts. But getting that adoption is incredibly challenging because they now have to go talk to 14, 15 different stakeholders in a large organization. And the larger it gets, the more the number of stakeholders. So this issue seems to be fairly similar as well, right? You can't get adoption going with just one stakeholder saying that, yeah, this sounds like a good idea.
Right, right. And that's where I just keep going back to that it's going to have to be the end users who are driving this, who demand that when you're turning over data from the EPCs that are doing the design work to when they're asking for specifications on a new piece of equipment for a replacement, that they demand that they be written in the language of the 15926, so that, and from that, then it will have to be that their purchasing agents have to be adapted to be able to accept that language in there and convert it over into something that they can use, and that's how it'll be adopted.
Okay, okay.
So I think there's a question for you.
Yeah, there's a question here for me. So this has been as much a educational exercise for me on this standard more than anything else, and I don't see how it can be used for our company. Our company is a consulting firm that focuses on oil and gas, and we don't work with.
Well, if you're doing a conceptual study on a process of a facility, if they have all of those processes easily, the data for them in terms of their specifications to how they've operated to the maintenance schedules over the past 10 years, and that's what we're trying to get to, is finding an easy way to store all of that information and be accessed to your consulting firm. When you're walking into that customer, you say, I need to understand your plant, instead of walking it down for 3 days or whatever it may be, and I don't know necessarily. Maybe you're able to just extract that data out and immediately know what's really going on with that plant.
Yeah, that's a fair point if we were doing technical or engineering consulting, but we are mainly helping with management or strategy consulting, right?
Okay.
It's further upstream in the process. So a lot of the work that we do does it make sense to build a new LNG facility on the Gulf Coast, right? What do global markets look like? Is there going to be demand and things like that? But that's a fair point, right? I mean, it kind of something that I hadn't thought of, right? That it expands the applicability of this standard across a broader range of stakeholders, right?
And everywhere in there, there's reductions in time and money, which ultimately, to the people that are purchasing the gas, where we're talking about lower gas prices, and that's ultimately what we're trying to get to is.
Yeah, eventually, I guess if cost of capital projects go down, then they have a big impact on this. So, Matt, if you were to hazard, like, what is that $6.8 billion in cost, right? If you compare that to, let's say, global oil and gas capex in a year, right? It is roughly, in a good year, 2014, for example, global oil and gas capex was $800-900 billion, right? Today, it's more like a couple $100 billion. So we are looking at something like, 2.5-3% in cost. Do you see that as significant in terms of what it does to the competitiveness of some of these capital projects?
Well,
I guess.
So I guess I guess when you put it in numbers like that, where I'm thinking 1 or 2%, when you say it like that, those were 2004 numbers. But when I see it like that, I mean, in the oil and gas market, it's so competitive, though. 1 or 2% it could mean the difference of $100 million possibly to an organization.
No, yeah, I mean, I do see a couple percentage points in capital, in the cost of a capital project as being significant. I just was trying to understand as a supplier into the space, right? Now, in reality, what's going to happen is you're going to see those costs concentrate more towards EPCs than, let's say, suppliers of valves and equipment, right?
Right. So that's a good point. Like, what would be the cost savings necessarily for us? Because we're
Yeah.
at the point where we're specifying the equipment, where we're sending it out there to them. But it could help us in terms of being able to help customers if they have 1,000 SAMSON valves in the facility and they want to understand what's wrong with some of them. They want to specify new valves. They've got a new upcoming expansion going on where we can then go in there and look at their SAMSON valve data and be able to understand what's going on with their process to help them actually specify the right equipment that's going into there. Ultimately, I mean, if we adopt that and we offer those services, it makes us more competitive over the Mason Nealons of the world who aren't doing that.
Yeah. No, fair enough. So, I mean, also, I think that cost estimate is probably more associated with the capital cost component, right?
Yeah.
I was taking a quick look at the NIST study earlier, and seemed like it's more about the capital cost and it ignores the operating cost benefits, right?
Right.
And that's what you're referring
Well,
to.
and I think that because as you saw up there, it's 30 years in the making right now. And as the data science comes more and more, is the reason why we're here with this digital transformation, is that people are now still, as ISO 15926 continues to expand out, we're still understanding more capabilities of it. Where before it was just trying to make sure that the data transfer between there was easy to read, where somebody in another country can easily understand what's happening with the specification. Where now it's talking about where that data is being stored, how you easily access that, and what you can do with that. It's only gonna, as we continue to, as people come up here with more ways to what you can do with that data, it's only gonna continue to help in terms of no longer on the capital projects, but in terms of your maintenance, optimization of the plant 10 years
Right.
down the road.
No, fair enough. We're about a minute away, so last call for questions from the floor. Just go to slido.com, use the token IoT, and enter any questions in there. So Matt, just looking at the future, like if you were to put on your forecasting hat, right, what do you see happening with the standard in, let's say, the next 12 months and then in the next 10 years?
I think I think it's going to have to be, like I keep going back to, one of the major players in the oil and gas industry is going to have to come to the forefront and say, hey, this is from now on how we're going to do business. If you want to do business with an Exxon, a BP, a Shell, that you will have to conform to the ISO standards.
But do you see that happening anytime soon?
I do think so. As digital becomes more and more in there, and as digital becomes more of a bigger part of 15926, as people will adopt that, because before maybe they wouldn't see much value in sharing information, just easily accessing what the size of a pump
Yeah,
may be.
yeah.
But now it's more about accessing that data and how it operated for the past 10 years.
Okay. Excellent. Matt, thank you for doing this.
Yep.
Very informative.
Yep, no problem.
Thank you.